The universe is a vast and mysterious place. It is filled with billions of galaxies. Each galaxy contains billions of stars. These stars, like us, have a life cycle. They are born, they live, and they die. Understanding a star's life cycle helps us to understand our place in the universe. Stars are born in nebulas. Nebulas are giant clouds of gas and dust. Gravity pulls the gas and dust together. Imagine a cosmic dance, particles swirling closer and closer. The nebula shrinks and spins faster. As the nebula collapses, the center gets very hot. This hot core is called a protostar. The protostar continues to gather material from the nebula. It grows hotter and brighter. This process takes millions of years. It's a slow and steady cosmic waltz. The protostar is not yet a true star. It is still gathering mass and heating up. The protostar's core is getting hotter and denser. The intense pressure and heat at the core are crucial. These conditions will eventually trigger nuclear fusion. Nuclear fusion is the process that powers stars. It's like a cosmic engine igniting. Hydrogen atoms fuse together to form helium. This process releases enormous amounts of energy. This energy makes the protostar shine. Eventually, the protostar becomes hot and dense enough. Nuclear fusion begins in its core. The protostar then becomes a main sequence star. This is a pivotal moment in a star's life. The main sequence is the longest stage in a star's life. Our sun is a main sequence star. It has been shining for billions of years. During this stage, the star is in a state of equilibrium. The outward pressure from nuclear fusion balances the inward pull of gravity. Stars on the main sequence come in different sizes and temperatures. Some are small and cool, like red dwarfs. Others are massive and hot, like blue giants. The mass of a star determines its lifespan. Massive stars burn brighter but live shorter lives. The sun will spend billions of years in the main sequence. It provides the energy for life on Earth. Eventually, the sun will run out of hydrogen fuel in its core. This marks the beginning of the end of its life cycle. Section 4. The Twilight Years. Red giants and supergiants. When a star runs out of hydrogen fuel, its core contracts. The outer layers of the star expand and cool. The star swells up and becomes a red giant. Red giants are much larger and cooler than main sequence stars. If the star is massive enough, it becomes a supergiant. Supergiants are even larger and brighter than red giants. These stellar giants are nearing the end of their lives. They are running out of fuel and facing a dramatic transformation. Red giants and supergiants lose mass through stellar winds. They expel their outer layers into space. This creates beautiful and intricate nebulae. These nebulae are the remnants of dying stars. Section 5. Stellar remnants. White dwarfs, neutron stars, and black holes. The final stage of a star's life depends on its mass. Low-mass stars like our sun will eventually become white dwarfs. White dwarfs are the hot, dense cores of dead stars. They slowly cool down over billions of years. More massive stars will explode as supernovae. These explosions are some of the most powerful events in the universe. A supernova can briefly outshine an entire galaxy. The remnants of these explosions can form neutron stars or black holes. Neutron stars are incredibly dense objects. They are composed mostly of neutrons. Black holes are even stranger. Their gravity is so strong that nothing, not even light, can escape. The death of a star is not the end. The material ejected during a star's death enriches the interstellar medium. This material can eventually form new stars and planets. The cycle of stellar life and death continues.